Okay, test review number 2, and then I'll give you one to work on tomorrow on your own. Okay, I'm gonna let you cross out find the y-intercept. I don't care. I don't need you doing that on this. Determine whether each function is an example of exponential growth or decay. Then find the y-intercept. Okay, 0, 1, 2. So we're going to take 100 times 0.25 raised to the power of 0. That's 100. Again, the reason why that's 100 is because anything to the 0 power is 1, and taking 100 times 1 is 100. Now, 0.25 to the first is 0.25. When I take 100 times 0.25, 100 actually goes down because we're multiplying by a number that is less than a whole. So 25. And then when I raise the 0.25 to different powers, it just keeps on going down. So that's an example of decay. Now, one way you can find growth decay, you can do your table. That'll work. You can also look at the base of the exponent, 18. 18 is greater than 1, so that's going to be a growth. 1 whole. Now, a fraction, if you're not really great with fractions, you can quickly divide 5 by 3. That's greater than 1, again, okay? So that's an example of growth. Now, the 1/5, because that's your starting number, okay? You don't pay attention to that necessarily, okay? So I go 1 divided by 5. That is less than 1 whole, so that would be an example. That's less than 1. That's a less than 1, so that's decay. Okay, then your favorite, the graphing, okay? Just look at what you got. It says y equals 2 to the power of x minus 5. First off, just worry about the powers first. And then you have your asymptote. Whenever your independent variable that you're going to be putting numbers into is a power, there is going to be that asymptote line. That's that line going this way where you never cross. It always starts off at 0. So I take 2 to the power of 2, that's 4. Don't do the minus 5 till you have your y's all set. 2. Anything to the 0 power is 1, and then this isn't going to be -2 and -4. What they do with negative powers, and don't write this, just watch. If I would do 2 to the -1 power, remember when you have a negative exponent, if you put a 1 over it, then you can make it positive. So that's 1 over 2. So I'm expecting when I plug this in, it's going to be 0.5 because that's the same as 1/2. Okay, 0.25. Okay, now you have to transform your graph. You need to subtract 5 from all your y's and your asymptote, because that's going to translate all those points down 5 units. So 4 minus 5 is -1. 2 minus 5 is -3. 1 minus 5 is -4. 0.5 minus 5 is -4.5. 0.25 minus 5 is going to be -4.75. And then on the asymptote, 0 minus 5 is -5. So I can never cross -5. It's like a boundary. Okay, so 2 -1. 1 -3. 0 -4. And then you really don't need to graph the decimals, because all that happens is those points go infinitely upward. And then as I move this way for x, when x starts being negatives, then it will just get closer to the asymptote, -5. But it will never actually cross it. Domain and range, okay? Now, if you see arrows on both ends, your domain's all. Now, your range, you just go with the asymptote, -5. And you're above it, okay? All points are above that line, so it's less than, but they never touch it, so that's why I'm not putting the line. If I put that before, it's by accident. Okay, now the next thing is just something you kind of got to memorize. How to take an exponent expression, because 3 to the 4th is 81. If I take 3 times 3 times 3 times 3, that's 81, and write it into a different notation, logarithm. So you're going to write the word log, circle your little power, that goes here all by itself. Now the power's base 3 comes down here, and then you put 81 behind it. Log base 3 of 81 equals 4. Okay. All right, so again, I write the word log. Whatever the power is goes here all by itself. Then the power's base goes here, and then 1 over 64. Okay, now on the next page, you're just multiplying out. You're trying to figure out how many 7s it takes to multiply to 343. So 7 times 7. I know that's 49. We'll see about that one. Boom, 343. Okay. So that's 3 factors of 7. So it's 3, because 7 to the 3rd power equals 343. Okay, next one. 8 would be the factor to multiply to try to get to 512. I'll put equals 343 there so you can see how that works. So 8, that's 64. We keep going. See about that. There's 512, so that's 8 to the 3rd power. Remember, a logarithm is always equal to a power. Okay, that's a 9. So you're trying to get it. The product is 6,651. Then 9 times 9 times 9. Nope. Keep timesing by 9. I'm there. So 9 to the 4th power is that, so it would be 4. Now, when you have a fraction with a 1 on top, you can just ignore the 1 over it and just use 16 as long as you put the negative there. So we're going to try to get a product of 16 so I can reciprocate the product. So 2, 4, 8, 16. Okay, so 4. Okay, now the next page, or no, you'll be okay on these. Write the expression as a single logarithm. So you write 1 log with its base, then make 1 parentheses. Put x. If we have minus, we put a division bar, not a dot, and then b. These numbers in the front come around, and it's x to the 6th power and b to the 3rd power. Okay, expand into multiple logarithms. It's like you're taking this going backwards, okay? So you have 3 factors, 1, 2, 3. So you would need 3 logarithms. Log base 2 on all of them. Okay, so 8, x to the 3rd, y to the 4th. Now those powers are going to come around back to the front like they are here. And then times, when I see dots, it means I add them, okay? There you are. Really, these problems don't take a long time. You just have to know the procedure. Some of them you have to memorize, okay? Okay, now I'm solving an equation for a power. I need to know what that 4x equals first. There's a plan A and a plan B. Plan A is to put equals 243. And plan B is if that doesn't work, we're going to use log over log. Okay, it's kind of a plan A, plan B. So first we'll multiply 3's to get to 243. 1, 9, 27. That's 81. Boom, 343. So I don't need the log over log. So that is 5 factors of 3. So the exponent is 5. 3 to the 5th is 243. So 4x equals 5. So then what's x? Well, we'll divide by 4, and that's 1.25. Again, this is kind of a similar problem. You got to find out what the exponent equals. 3 to the what power is 20. Okay? So x minus 4 equals. Now remember how I can find the power. Plan A is to multiply 3's to get to 20. 9, 20. Okay, that did not work, so now I need to use my log over log. So we put the number I'm multiplying by on bottom, and then the product I'm trying to get to on top. So log 20 divided by log 3. 2.73. So that's what x minus 4 is equal to. Then to find the actual x, you just need to plus 4. That's 6.73. Okay, the next one, you gotta get, I want to put that, I keep forgetting that. There's some stuff I forgot to write in this too that I want you to see, because it'll help you. Okay, let's get rid of the logarithm. First we go parentheses x, and then what the log is equal to is my power. So this, whatever's here, I put as a little number as a power, and that is what the base of the power is. So this to the power of this. Actually, let's write that as a 3, please, so you can see what's going, because the 2 4's there don't really help you that much. Okay, so that 4 is still the power, and now the base will be 3. Okay, so pretend that was a 3 instead of a 4. Okay, so I just take 3 times 3 times 3 times 3, I got 81. Okay, I need to write a couple hints here, and I will write them on your test. So I'm going to write hint ln, okay? Because I see e, I'm going to need to use ln. Here, if I see ln, I'm going to need to use e. Now, before I go to the ln, I got to cancel the I got to unmultiply by 4, which should be divide. So that would be 50. Okay, now we can go to the ln to cancel the e out. But then we have to ln on the 50 side too. So we have 3x. And I find what the natural log of 50 is. It's really just a procedure you have to use on your calculator. 3.91. Keep solving. Divide by 3. 1.30. Okay, next one. Hint E. When you have to use E, you can go to that right away. Okay, as long as there's nothing in front of the ln, which I'm not going to put there. Okay, so and remember, when you use E, you got to put E in the bottom left. Okay, so that cancels, and I have x minus 5, similar to what I had here. Now on the other side, instead of ln 3, we go e to the third. So second ln, and the e pops up to the third power. 20.09. Then you add 5, that's going to be 25.09. Okay, then you got 2 story problems. You're going to use a times b to the x power equals y on both of them. I'll just tell you that. A bank account contains $5,000. The interest rate is 4% per year. How much money will the account have after 3 years? So again, dollars in years, knowing that x is the year, x is always our time, y is our money. Dollars per year, we don't have a dollars per year, it's 4% interest per year, not $4, okay? So, it's plus 4%. So with that percent, that means it won't be a linear, it'll be an exponential equation. A times b to the x power equals y. So I want to know what these things all are. Remember, the a and the y are the same label. So if y is going to be money, the a's got to be money too. The a is where you started with, 5,000. And we don't, the y is where you end at with the money. We don't know that, okay? That's what we're figuring out. So we're going to keep that y in the equation. Might as well just put that. Now, b is your percent, but you got to add 100 to it. So plus 4%. And then you need to rewrite it in decimal form. So 1.04. and x is the years, 3. Okay. Now I plug those 3 in where they go, and I solve for the y, which is easy to do when it's y. 5,000 times 1.04 is my b, raised to the power of 3. And y is by itself, so I can just plug that into the calculator. 5,000 times 1.04 to the power of 3. We got $56,024 or $25, whatever you prefer to put. I don't need the cents though. Okay, so we solve for the money. Okay, now next one is similar, but the variable that we're solving for moves around. As the town gets smaller, the population of its high school decreases by 6% per year. The senior class has 160 students now. In how many years will it have 100 students? Okay, so we've got years and students. Be careful here. X is years, Y is student. X is always the time. Students per year, it's 6%, but it's decreasing. So that'll be 100% minus 6%. I'm just going to write that down, and I'll come back to it later. So again, that's an exponential growth, or decay this time. Not that it's any different than writing a growth, but it's still a times b to the x power is y. Okay, remember, A and Y have the same label. Y is students, and so is A. The A is the beginning amount of students. So we have 160 now. We're going to end at 100. The B, I come over here and just finish doing my percent. 94%, move the decimal twice, 0.94. Now, X is the years. Now, we don't have that because that's what we're trying to figure out. So, question mark. So, A is 160. Then B is going to be the 0.94. X we don't have, so I put a power, the symbol there, equals 100. Now, if you have a power, you need to parenthesize that in its base, okay? Because you are going to have to use the log over the log. So we have to unmultiply by 160, so I divide both sides by 160. .625. Now I'm ready. That goes on bottom. The product that it's equal to goes on top. Whatever the x power, whatever is to the x power goes on the bottom. Okay, it's not always necessarily the bigger on top, smaller on bottom. Okay, so log 0.625 divided by log 0.94. Okay, I got 8, so x would be 8 years.